And yeah, good afternoon, everybody joining from Amsterdam time zone. And well, thanks for joining this session. My name is Serkan, working as solutions architect at Cloud to Technology Solutions. Last years, I had quite some luxury of architecting and developing some EKS clusters, quite some EKS clusters. And today, in this talk, I would like to talk about actually preparing an EKS cluster for production workloads. I will say production environment, but when I say production environment, actually I'm talking about production grade environments, not only specifically a production environment. And yeah, and half of this talk will be around technology, and half of it will be about process and governance related. And I'll go through some topics. We have very limited time. I'll try to just raise some questions, point out some consideration points, and hopefully it will create a checklist for you for your production environment. I'm not going to read the agenda, but these are the topics I would like to talk about if I can. So let's start. Well, a production grade EKS cluster actually starts with production grade environment. So first, how you are creating your EKS cluster. Creating an EKS cluster is quite simple, very easy. Basically, you go to console and choose a nice name, and then choose the version, and if you wish, decide on some tags, and then you click the button. Interesting enough, it's easier than creating an AWS auto-scaling group. Very simple. But if you're running workloads at production, there are some hard requirements. And one of them is actually you should be creating, of course, not only your EKS, but overall AWS environment with code, and you should be also updating it with the code. That's one of the hard requirements. And so we don't go to AWS console and click the buttons. And another thing is you would like to have minimum, but it is really minimum 2 environments. We are talking about 3 or 4 DTAP environments. And our motivations are, besides from having a proper besides from all advantages of a DTAP process, specifically at Kubernetes during the project lifetime, you are going to upgrade your cluster. You're going to make changes on your namespaces, on your networking configurations. So you would like to make mistakes. It's either human mistake or logical mistake. You would like to make these mistakes at non-prod environments. So everything starts with actually creating a proper EKS cluster with a proper way. And there are quite some technical considerations before you should keep in mind before you start creating your cluster. And first one is about networking. Basically, you would like to have you would like to have public subnets and private subnets. Your workloads, your EC2 instances, your containers are going to run at private network, and your load balancer created by Kubernetes should land at public subnet. And talking about subnet, another important point we have to highlight is the size of the subnet. When it comes to consuming IP addresses, EKS is very hungry on that sense. For each pod, but not only for deployments, for each pod, for each init container, for each tasks running inside your cluster, you are going to consume one private IP address. And especially if you are starting and stopping your pods, at some point you will notice that AWS don't see them as empty IP addresses, but they will be still hanging as in use state, so you won't be able to use full of your IP addresses. So based on experience, try to choose very big subnet. You are going to need it at some point. And another thing is, while creating EKS cluster, API endpoint should be whitelisted. So if you are connecting from different endpoints, different locations, keep in mind that you will need to give static IP address to Kubernetes cluster. And another thing, during the configuration, you will notice that it will ask you whether you would like to access your EC2 instances of your Kubernetes cluster. You would like to disable it because you don't need to SSH to EC2 instances. Configuring the worker nodes, you have 2 options. It's either auto-scaling group option provided by AWS initially, and then node group option, the newest option. There are differences. There are some missing functions. I'm not going to talk about it because it they change over the night, but look at the limitations and documentations before you start configuring your worker nodes. And we created our code. On this case, we decided to use CloudFormation, and then our code is ready. We're gonna execute this command. But the question is, who is going to press this button? It makes a difference at AWS. It's a design decision by AWS. Whoever creates the EKS cluster, whoever is not correct word, the IAM user, it can be person or system account, that IAM user actually is owner of the admin user at the Kubernetes cluster and the only admin user at the Kubernetes cluster, which can be changed. So because of that, we recommend creating the cluster with your CI/CD tool. If you are using Jenkins or whatever you are using, create this cluster, executing this command if you are doing like this from your CI/CD tooling. So don't touch your cluster with a person account. So finally, our EKS cluster is ready. So we see it on the console. The next thing is about user management, how we are going to talk with this Kubernetes cluster. And when we talk about user management, actually the question is what you need, what kind of access you need at your Kubernetes cluster if you are talking about production grade setup. So basically, kubectl is equivalent of modern time equivalent of SSH. And we had this conversation 10 years ago. I hope we solved this problem, but somehow it came back. If you think that you need kubectl access and make changes at your cluster, most probably you are missing some knowledge or some components. So you try to fix this instead of arranging access, configuring different access levels. And if you really need to give kubectl access, do it with the IAM person accounts and only give read-only access. That's quite important. And AWS documentation is quite nice. It explains how to do it. And we also solved how we are going to access the Kubernetes cluster. And the next thing is actually how our deployment strategy and cost structure will be. When we are talking about resources at Kubernetes, we actually, on the high level, talk about two different resources. One is project resources, business related, your project, and another one is system resources. Think about ingress, storage, logging system, security related resources. So doesn't mean that you have to have two different folders or two different repositories, but always think that you will have two types of resources. So define your code structure based on this. There are some considerations you should keep in mind in order to define your deployment strategy, but also the code structures. And they are whether you have multi-tenant or single-tenant project, how your team topology is. It really makes a difference. If you have one single development team, it's different. If you have multiple development teams, it's different. If you have an operations team, they are responsible from deployments. If you have a security team, in an enterprise environment, they are responsible of security of this your Kubernetes environment. That's completely different story. So you should define your code structure considering these points. There is no actually true and false. You just need to define based on your requirements. And finally, our repository is ready. What we are going to do is hopefully not this. So we don't want to touch our cluster manually. There are some hard requirements if we are talking about really proper environment. First one is, as we mentioned before, we would like to deploy resources with CI/CD process without any manual interaction. And you have to be using a templating engine in order to avoid duplicating the code. And also, when you make a change, you don't want to. You would like to have similar environments over DTAP environments. So you need a templating engine. Other than that, that's not very popular requirement. Somehow garbage collector at Kubernetes is very critical. So what we see most of the time in our clients that they deployed a service some time ago, a year ago, and they removed it from the repository, but the resource is still in in the Kubernetes cluster. So at some point you will have quite some garbage at your cluster. So whenever you remove from a repository, you want your deployment tool to remove also these resources from your cluster. And some other possible requirements. We discussed about deployment strategy. Now we are talking about which tool we're gonna use. Luckily, I'm not gonna promote any tool here. There are lots of beautiful tools, but first define your requirements. Decide whether you need a single repository or multi-repository, whether you need a UI or GitOps kind of deployment mechanism. You're gonna do feature-based or traditional release-based deployments. You need canary deployments. Do you need auto-release mechanism? So these are some requirements. Put them in a list and then look at these beautiful tools based on these questions, based on these requirements, if they're applicable to you. And there are some options. Some of them are my favorite. There are also some other very nice tools. Look at them. One of these are going to solve your problem. We also managed to deploy our resources, and next thing we would like to do, understand why our deployment doesn't work, because at first try it's not going to work. In order to do so, basically we need a logging, and it's also easy. We are just going to use kubectl logs command. Hopefully not. Again, it's very important, sort of hard requirement. If we are talking about a professional environment, you have to be exporting your logs outside your cluster, because basically you will need it for auditing purposes. Look back and see which user executed which command. And another thing is you need a historical view for the root cause analyze. And also you would like to have some ready-to-use search queries, preferably in an interface where you can just go and start debugging when you have a problem. Another important point is you would like to have an alerting system. Because basically Kubernetes solves lots of problems in behalf of you, but that's also a bad thing. If your deployments are failing overnight again and again, you would like to understand why it's happening. Okay, we also managed to have tools to debug. So next thing is actually see our Hello World example in the browser or through an API call. And we would like to expose our services from the Kubernetes cluster. It's also quite easy. If you go to Kubernetes documentations, basically you are going to create a resource with type service, and then you're gonna choose the type, as load balancer, and then it's going to create a load balancer at AWS level, and you're gonna see your Hello World 1. And for application 2, you're gonna create another load balancer. For application 3, you're gonna create another one. And for your application 20, you're gonna create another load balancer. What will happen, that's a real screenshot from a client of mine. At some point, you're going to have lots of load balancers with a very specific name. It's very clear what it does, and you don't know who is doing what. In order to avoid this, so it's very easy to end up at this situation. In order to avoid this, before that, the consequences of having such a structure is you will have lots of extra cost because you are paying per hour at the load balancers, and you would like to configure configure SSL configuration, and you're gonna duplicate this configuration at each load balancer. And there's a governance problem, lack of visibility and accountability. That will be also hurting you at some point. And if you would like to integrate your endpoints with web application firewall or with CloudFront caching, it's there's no direct integration possible with some over engineering, but you really don't want to do that. So basically, that's not a setup I would recommend. So a recommended setup is the following. So basically what we do is we create a CloudFront from AWS code, and from the Kubernetes side, we are creating a load balancer on the one load balancer, on the one service type load balancer, and it can be network load balancer, and then we direct all of these connections to the ingress, and at the ingress level, we actually manage all of the connections to redirect inside the pods. There are quite some advantages. So basically you have one load balancer, you have CloudFront and WAF integrated. Actually, I have a list of advantages here. So basically you have one entry point, with well-defined security group configuration. And any new service, when you introduce a new service, you don't have to think about CloudFront caching, web application firewall integration. They already come with these features integrated, and service changes handled automatically, and SSL offloading will be at the CloudFront level. You don't have to think about it every time. And also access logs will be at CloudFront level. If you have a security team, they will be able to control it at the CloudFront and web application firewall level. You can see details on a blog post. So sorry, I have to talk very fast because I have lots of content. If you have a question, please ask it at the end. We will have like extra 5 or 10 minutes. I would be very happy to explain in details. So we also have a service running right now. We are able to see it on the browser. The next thing we would like to make sure is it's ready for the world, because it's going to be a very popular service. So we are talking about scaling and auto-scaling. Keep in mind that most probably you already know, EKS doesn't come with auto-scaling configured. And if you configure EC2 auto-scaling, it also doesn't mean that it is pod auto-scaling. So it won't be enough configuration. So horizontal pod auto-scaling is required for cluster auto-scaling. I won't explain how it works, but the important thing here is you would like to know what horizontal pod auto-scaling is, and then you would like to configure cluster auto-scaler. That's what you need. Cluster autoscaler is actually one single pod. It talks with Kubernetes resources. It also talks with AWS autoscaling configuration, and it adds and removes EC2 instances. It is well defined at AWS documentation, except that this line, don't touch your cluster by hand. That's again hard requirement. Put it to your repository. One important thing is cluster autoscaler needs permission to adjust desired capacity. So you would like to give a permission to your specific pod, but also documentation gives this permission to the instance role. But if you do that, all of your pods, any other pods, will be able to talk with autoscaling group configuration. So instead of doing so, you would like to configure IAM roles for service account setup. Hopefully, I'll have time to also talk about it. Talking about it, okay, I'll be able to. IAM roles for service accounts. It's basically when you need to talk with AWS resources, especially if you are adjusting something, you can give permission to your specific role. And what you would like to do is you would like to create an IAM role on AWS, attaching a policy on it, and then you integrate this IAM role with a service account at Kubernetes cluster, and then you're going to bind this service account with the container. So meaning that if we are talking about autoscaler, only autoscaler pod will be able to talk with autoscaling configuration, not all of your pods. If you don't do that, for example, if you are reading scripts or editing Route 53 or accessing SQS or S3 or any other AWS resource, all of your pods will be able to do so. So to avoid that, you have to use IAM roles for service accounts at production grade setup. So finally, we configured an EKS. It's almost similar with ECS functionalities. I wish I had the time to talk about when to use EKS, when to use ECS, but I just put a question here. Make sure that you really need a Kubernetes cluster. There are also some other alternatives at AWS. So finally, after having our Kubernetes cluster, we will also think about persistent files. I mostly hear that from friends, they say, hey, why don't you use S3? Yeah, that's very smart, but in reality, you will end up seeing some third-party applications. They don't support S3, or some other legacy applications. Actually, it's very difficult to rewrite. So especially at the migration projects, we mostly end up configuring /data folder inside the pods in order to keep the persistent data. And this /data, we are mounting it with the Elastic file system. You may ask why not EBS? Specifically EFS, if we have time, we will be able to actually explain why EFS. In order to integrate EFS with Kubernetes cluster, we are using an EFS provisioner with a nice new name, AWS EFS CSI driver. AWS has a blog post explaining it. You have two options. You can have one EFS and multiple PV and PVCs, or you can also create one Elastic file system for each PV and PVC. It's more about how you configure your AWS environment. Don't forget your EFS backup, and one single line can really make your life difficult. By default, EFS provisioner claim policy comes with delete. You would like to make it retain, keep in mind. Secret manager is the next one. It's very easy to manage secrets at Kubernetes. Looking at the CNCF Kubernetes documentation, you just create secrets like this. Hopefully not. We will do something else. There are two problems. One, we don't create resources at Kubernetes manually, as we talked before, but with the code. But on the other hand, we also don't want to put our secrets inside the code. So the solution is simple. Actually, we are going to use an external vault provider. There are options. The options are obvious one, HashiCorp Vault, but you can also use AWS Secret Manager. I personally use AWS Secret Manager quite a lot because basically you don't have to deal with something else. You are already on AWS, so it's quite comfortable using it. And how we are going to integrate it? Look at AWS Secrets Manager. I will speed up a bit. Basically, it reads secrets from AWS Secret Manager and puts it to Kubernetes Secret. And at number 5, you see that without seeing the secret, actually, from the pod, you are able to access to your secrets. I will speed up a bit. As a result, what we are trying to do is actually, we are trying to apply well-architected framework to the cluster. That's what we are trying to do. And when you are making a design decision, although these 5 pillars are not for EKS or Kubernetes cluster, but that's just a perfect reference. Look at here and try to implement these pillars on your Kubernetes cluster. I have quite some other content. I'm not sure whether Walter will allow me to go 2 more minutes. I will try. If doesn't, I will shut up very quick. I would like to talk about one more thing, that it is about auto-scaling speed. So when we configured auto-scaling, in reality, you will see that when you add a new pod and when it's at the pending state, it takes mostly 3 to 4 minutes, even if you configure your auto-scaling very well. So to avoid it, you have some option. It's highly recommended that production environment. You can keep some percent, 10% of your resources idle using the over-provisioning approach. It's not a resource, but it's a configuration. There are quite some, what you need is an empty deployment, priority class, and some other configurations. Doing that, you will have some extra resources. You can actually over-provision. You can create some extra resources. Always keep the cluster busy, and whenever you need a new pod, it's going to kill these pods, empty pods, and then it will put your new pod, required important pod, inside your cluster. Most probably, I am out of time. Okay, I'll continue. I'm glad I had some extra content, Walter. Am I good?
Go ahead. Yeah.
Oh, perfect.
As far as I'm concerned, you can say, unless you want to answer questions, you're welcome to do either one of those.
Okay, let's start with questions, and if not, I'll turn back here. I still have some extra content.
Yeah. Okay. We have a number of questions.
Thanks a lot for listening. Sorry, I had to talk quite fast in order to throw out some points and raise some question marks. Hopefully, they were helpful. Yeah, feel free to reach me with anything. Please do so. I'll be at this beautiful grip interface. Also, LinkedIn, Twitter, wherever you can. I'm ready for questions, Walter.
Awesome. This it was a really cool whirlwind through EKS for production, so quite nice. And I personally don't mind the high speed, and I think you covered off quite a bit of topics. We have a number of questions, and I'll just start at the top. Karen, actually the next speaker, asked, "Is there a way to use overlay networking instead in EKS instead of AWS VPC CNI?"
Which I don't know. I don't have an answer.
Okay. The next question is Chunming asking, this thing is scrolling back. Why did you choose to use EC2 worker nodes instead of Fargate worker nodes?
Yeah, I didn't choose. You have different options, but keep in mind the pricing model is completely different. What I can quickly tell is if you have some resources running all the time, and you are keeping your EC2 instances all the time busy, it will bring you a different cost. But if you have some services they are running from time to time, or they are running during the day, and other 16 hours they are slightly empty, you will end up with a different costs. So it's more design decision. You have 3 different options.
Yeah. Okay. Cool. The AWS load balancer controller. The question is by Masoom is how can you improve this setup with the new AWS load balancer controller? What does it mean for EKS?
Yeah, well, indeed, actually, while I was preparing the presentation, I thought about also including this new setup. It's quite, as far as I know, it's still at the developer preview thing. And it will be very helpful actually, because from the main problem here is we are having with not only with the load balancer but in general with other AWS resources, you have a way of managing your AWS environment, but when you go inside the cluster it's completely different world. But inside this Kubernetes cluster you still would like to use quite some features, for example API gateway, different functionalities of the load balancers kind of things. I expect that AWS is going to introduce more and more this kind of services, so we will be able to use functionalities and features of AWS from talking inside the Kubernetes cluster. Specifically at the load balancer level, I cannot think of something very quick, but I think we will have more and more features actually integrating Kubernetes with AWS resources. Very good question.
Yeah, I think one of the things that I've seen mentioned is I watched one of Corey Quinn's previous talks, and there he raised the issue that if you are using AWS billing to separate costs by department, that's really great. You can use tags and all kinds of advanced strategies to figure out who spent what. But with Kubernetes, at least at the moment, as far as I'm aware, all your workloads become one. So if you have 5 different departments that have containers on your Kubernetes stuff, then you have no more way to tell who used how much data. And I could see that there's a tighter integration.
Yeah, definitely true. We are using currently some external tools. Basically, we label some of the resources, and we expect from this external tool to actually separate them based on CPU and memory and actual resource allocation to have a guess, actually split it to the different departments. But true, not as you said, I mean, not only the cost topic, but when it comes to everything, you have lots of features on the AWS. But when you go inside the Kubernetes cluster, you are not able to actually integrate with, take advantage of these features. That's what AWS, as far as I can see, trying to do.
Yeah. Okay. Cool. Let me see if there's a last question. We have 2 more minutes. Which ingress controller are you using? Nginx ingress?
Yeah, I'm using Nginx ingress just because it works in my case. But yeah, as most probably the person asking the question also knows that there are also other options. But AWS documentation also redirects you to Nginx ingress.
Okay. Yeah, cool. Anyone running Graviton 2 in a mixed architecture EKS cluster is the next question. I haven't seen anyone running Graviton 2.
Yeah, not at the moment, not me.
Okay. If you want to manage your EKS cluster as code with CI/CD pipeline, I see only Terraform EKS module is the best solution. Others like EKS, CTL, CFN templates are not mature enough. I know
I
it's not
wouldn't.
really a question; it's more a statement.
Yeah. Well, at least my opinion, I wouldn't agree. We are managing quite some EKS clusters with CloudFormation. Besides, from some features are missing. For example, whitelisting has to be with the API call. CloudFormation is very mature actually and very stable, and I really prefer using CloudFormation.
Okay, yeah, cool. And the last question is, will there be a recording of the session? And yes, there will be. We are exactly at 3 o'clock. So
Wow.
I would like to thank you very much, Serkan. Anything last you want to say to your viewers?
Well, thanks for joining the session, and thanks to organizers for organizing this very nice event.
Yep.
And feel free to please ask questions somewhere. I think we have enough channels to communicate.
For sure. Yeah. Thank you very much for giving the talk. I mean, I consider my job to be easy. I just need to talk through some connections. Your job is much harder, saying useful things about this stuff.
This is just fun, believe me, just fun.
All right. Thanks, Serkan.
Okay. Thank you very much.